All right, today we're going to tackle a fascinating cognitive puzzle. It's this little mental glitch that trips up pretty much everyone. I'm talking regular folks, even highly trained doctors. It's called base rate neglect. And I promise, by the end of this, you're going to have a brand new tool for thinking more clearly. So let's just jump right in. I want you to imagine this scenario. You go to the doctor, you take a test for a very rare disease, and the result comes back, and it's positive. So what's the first thing that goes through your mind? What do you think the odds are that you're actually sick? Okay, now let's put some numbers to this to make it real. First off, the disease is really rare. It only affects 1 in 1,000 people. That's our base rate. Second, the test itself seems amazing. It's 99% correct at identifying people who are actually sick. And third, for healthy people, it gives them the all clear 95% of the time. So on paper, this looks like a super accurate test. So, you've got a positive result from a test that's 95 to 99% accurate. What's your gut tell you? If you're thinking, well, the odds have got to be around 95%, you are not alone. Not at all. In fact, studies show that's the exact same answer most doctors give. And it's completely wrong. And that's what makes this such a shocking puzzle. It really shines a spotlight on this huge, huge blind spot our brains have when they try to handle probability. The real probability that you have the disease, given that positive test, it's just about 2%. Yeah, you heard me, 2, not 95. So what on earth is going on here? Okay, let's unpack this surprising answer. It all boils down to a cognitive bias that is just incredibly powerful and super common. That mental hiccup you just felt, it's got a name: base rate neglect. It's like our brains see the shiny new piece of evidence, that positive test result, and we just laser focus on it. And in doing so, we completely forget about the most important piece of background info, the fact that the disease itself is incredibly rare to begin with. Now, I know that 2% figure feels deeply wrong. It's just counterintuitive. So let's break down the math in a really simple visual way. Because I promise, when you actually see the numbers laid out, it all just clicks into place. Okay, check this out. Let's just imagine we test a huge population, say 100,000 people. Since the disease affects 1 in 1,000, we know that out of this group, exactly 100 people are actually sick and the other 99,900 are healthy. Simple enough. So let's start with the 100 sick people. The test is 99% accurate, so it correctly catches 99 of them. These are our true positives. Now, here's the key part. Let's look at those 99,900 healthy people. The test has a 5% false positive rate. Well, 5% of almost 100,000 healthy people is a lot. It comes out to nearly 5,000 people, and those are all false positives. And right there, that's the whole thing. If you add up everyone who tested positive, you get a little over 5,000 people. But out of that whole group, only 99 are actually sick. So your personal chance of being one of those 99 true cases is 99 divided by 5,094, which gets you to just about 1.9%. The huge wave of false alarms from the healthy population completely drowns out the tiny number of real alarms from the sick population. You see, this isn't just a quirky math problem. It points to a fundamental rule of logic and critical thinking. That starting probability, the base rate, always matters. A lot. This quote really just nails it. The key insight here is that even a fantastic test is going to spit out mostly false positives when you're looking for something that's really, really rare. Our brains seem to be hardwired to just ignore that initial probability, but it's absolutely crucial. And hey, if you're into the math side of things, this isn't just some simplified model. It's all backed up by the formal mathematics of something called Bayes' theorem. That's the precise mathematical way to calculate exactly how you should update your beliefs when you get new evidence. Our little table is just a simple way of showing how that theorem works in the real world. So why should you care about any of this? Because this little cognitive glitch has massive, and I mean massive, real-world consequences. This is so much more than just a math problem. Let's look at where this thing pops up in a few high-stakes situations. In the courtroom, at the airport, and yeah, right back where he started, in the doctor's office. So picture a courtroom. A lawyer says the suspect's DNA is a 1 in a million match. Sounds like a total slam dunk, right? Case closed. But what they're doing is encouraging you to ignore the base rate. In a country of 330 million people, a 1 in a million profile means about 330 other people would also be a match. Now, it's still powerful evidence, for sure, but it's not the open and shut case it sounds like. Or think about airport security. We screen millions and millions of travelers every day, all to find an extraordinarily rare threat. The base rate of any random passenger being a real danger is almost zero. So what does that mean? It means even with incredibly accurate screening systems, the overwhelming majority of alerts, the bags pulled aside, the extra pat-downs, are going to be false positives. That's just how the math works out. And this brings us full circle, right back to medicine. That medical test we talked about, it wasn't just hypothetical. In real-world studies, when doctors were asked about mammograms, the vast majority dramatically overestimated the chance that a positive result meant cancer, some guessed as high as 80 or 90%. The actual probability is usually somewhere between 5 and 15%. See, even the experts get fooled. So the big question is, how do we defend ourselves against this powerful bias? Well, I'm going to give you a simple, portable tool for critical thinking, and it all comes down to asking just one question. Here's the mental checklist. First, you run into some really specific, compelling new piece of info, a positive test, a shocking headline. Second, you can feel your intuition just grab onto that evidence and start running with it. The most important step is number 3, pause. Just stop. Deliberately interrupt that intuitive leap. And fourth, ask yourself that one crucial question. And that question is simply, what is the base rate? How common is this thing in the first place? Asking that one simple question forces your brain to consider the background context that it would otherwise completely ignore. It's a mental habit that can save you from anxiety, from flawed judgments, and from being misled by statistics. And honestly, it's the single most important takeaway from this entire explainer.